I told you a mistake smaller than a human hair could cost a company millions of dollars? Well, that's the reality in high-stakes manufacturing. Today, we're going to break down how these tiny errors create huge problems. And more importantly, we'll look at the powerful systems you can use to get rid of them for good.
Okay, so this right here, this is the world of CNC machining. I mean, these machines are the absolute backbone of modern industry. They carve super complex metal parts with insane, microscopic precision. We're talking about parts for industries like oil and gas, places where failure is just not an option. They really are marvels of engineering.
But here's the crazy part, the real paradox. Even with all this incredible tech, one top-tier company, a company with over 100 of these machines, was just bleeding money. Why? Because they kept making bad parts. So what was going on? All right, take a look at this. This shows you just how simple and expensive these mistakes can be. So that drawing up top, that's what the customer wanted. The picture on the bottom, that's what they actually got. You see those 2 extra slots that shouldn't be there? Yeah, in the engineering world, we call that a dimensional deviation. And it basically means the whole part is junk. And a mistake like that, it isn't just a piece of scrap metal. No, it's way worse. It's a whole chain reaction of waste. You've got wasted material, wasted time on the machine, and shipments that are now late. But the biggest cost of all? It's the broken trust with your customer. The customer who's counting on that part to keep their own multi-million-dollar business running. So to fix a problem this massive, you can't just wing it. You can't guess. You literally have to become a detective. You've got to systematically hunt down the root cause, digging past the obvious symptoms to find the real source of the problem. So let's see exactly how they did that. Okay, so their first move was to use a Pareto analysis. You've probably heard of this. It's based on the famous 80-20 rule. The idea is simple. Most of your problems, like 80% of them, usually come from just a handful of causes, maybe 20%. And wow, the results were crystal clear. A huge chunk of their customer complaints were all about one thing, these dimensional errors. That was the smoking gun. It told them exactly where to point their magnifying glass. Next up, they put together a cross-functional team, and they used this thing, a Fishbone diagram. And this tool is just brilliant. It's a way to visually map out every single possible cause of a problem, making sure you leave no stone unturned. They just brainstormed everything that could possibly be causing these errors across 6 key areas: management, people, methods, measurement, machines, and materials. And guess what? All that detective work totally paid off. The investigation boiled it all down to 4 clear-cut root causes. First, the tool setup was just wrong, a lot of the time. Second, there were no standard instructions, so every machinist was kind of doing their own thing. Third, the skill levels between operators were all over the place. And last, the quality control guys, well, they just didn't have the high-precision tools they needed to catch these mistakes before the parts went out the door. Okay, so they found the root causes. Awesome. But knowing why something is broken is only half the battle, right? Now they needed a solid plan for the how. How do we fix this? They needed a structured, repeatable framework to make changes that would actually stick. And that's where the PDSA cycle comes in. You might have heard of it. It was developed by the absolute legend of quality, W. Edwards Deming. It stands for Plan, Do, Study, Act. And don't let this simple name fool you. It's an incredibly powerful, scientific way to test out changes and just keep making things better all the time. So here's the breakdown. It's super simple. First, you plan. You figure out what you want to change. Then you do it, but you do it on a small scale and you collect data. Next, you study that data. Did it work? What happened? And finally, you act based on what you learned. You either roll out the change everywhere or you start the whole cycle over again with a new idea. It's this constant loop of getting smarter and better. And listen, this is really the key thing to get. The whole point of PDSA isn't about some one-time heroic fix. It's not about that at all. It's about making lots of small, smart improvements that add up over time. It's like a ramp, always going up. It's about building a culture where everyone is always looking for a better way to do things. But wait, there's more. Fixing problems after they happen, that's good, but it's still playing defense. The real goal, the ultimate win, is to build a system that's so tough, so resilient, that problems just don't happen in the first place. This is the whole idea behind something called lean maintenance. It's about switching from being reactive to being proactive.
And this quote right here, it just says it all perfectly. Downtime will not go away until you eliminate it, prevent it from happening in the first place. Think about that. You can get really, really good at fixing things when they break, but the problem will never truly go away until you stop it from breaking to begin with. It's a total mindset shift.
You know, when people think about downtime, they usually blame two things: operator error or bad maintenance. And sure, those are big ones, but lean maintenance really hones in on this third category, the one that most people ignore. It's the slow, chronic stress on the machine itself. Things like heat, vibration, dirt, contamination. These are the silent killers of productivity. So the big question is, how do you actually build one of these proactive, super resilient processes? Well, there's a powerful model for this called the productive process pyramid. Think of it as a blueprint for systematically stamping out problems and variation right from the ground up. And it all starts right here, at the bottom, with a solid foundation. This layer is all about creating total, absolute stability. The house analogy is perfect. You wouldn't dare put up walls on a crooked foundation, right? It's the same here. Is the machine calibrated? Is the environment controlled? Are the materials you're using consistent? You have to get these fundamentals absolutely perfect first.
Okay, moving up the pyramid, the next layer is process setting. Now, this is where you start using cool tech, like on-machine probes, to automate the whole setup process. And this is huge. Why? Because it attacks the single biggest cause of problems in most factories: human error. You literally let the machine set itself up perfectly, every single time.
All right, now this is where things get really, really smart. Layer 3 is in-process control. This means the machine can actually check its own work while it's cutting metal. That's amazing. Probes can measure the part and automatically make tiny adjustments for things like the tool wearing down or the temperature changing. It's all happening in real time to make sure every single part comes out perfect. And finally, we get to the very top of the pyramid: post-process monitoring. This is that final critical quality check. It's where you verify that the finished part meets every single specification, down to the micron. It's the ultimate proof, the final stamp of approval, that your entire process is completely under control.
So, does all this fancy theory, these diagrams and pyramids, does any of it actually work in the real world? Well, the results are, honestly, they're stunning. Let's look at the numbers.
Get ready for this, because it's absolutely incredible. By putting these process controls into place, one company saw their scrap and rework rate, that's the amount of junk they were making, plummet from a painful 12.1% all the way down to 0.00002%. That's basically zero. That's not just getting better, it's a total transformation. We're talking about 60,000 times less waste. Just wow. And what does that do for the company's wallet? For the bottom line? Well, take a look at this chart. Putting these controls in place can boost the profit from just one machine by hundreds of thousands of dollars a year. The investment doesn't just pay for itself. It pays for itself over and over and over again.
You know, the ideas we've talked about today, they aren't just for some huge multi-million-dollar factory. Every single process, whether you're building engine parts or writing code or even making coffee, every process has these little hidden problems, these sources of waste that are silently killing your performance. So the real question I want to leave you with is this: what are the hidden variables that are hurting your process, and what are you going to do to find them and get rid of them?